Okay guys, this is concept 63, solving rational equations, and there are two methods to be able to do these. The first one is proportions. It's just basically you have two ratios in the same on each side of the equal sign, so you do cross multiplication and then you just solve for the variable. Method 2, you use the least common denominator. You multiply each side of the equation by the least common denominator, and then you solve the resulting equation. Okay, let me shut the window because the helicopter is passing. Okay, sorry about that. So then, for number 1, right, I have two ratios on each side, so I'm just gonna, it's like a proportion, cross multiply. When I do that, right, I'm gonna get this expression here, and then I distribute the 4 in, so I got 4x minus 24 on the left side. That's equal to 7x. I subtract 4x from both sides, and I get negative 24 is equal to 3x. And so x, when I divide both sides by 3, x would be equal to negative 8. What you need to check is that when you plug it into the original, that it checks out, that you're not getting 0 in the denominator, excuse me. So you can see that it does. So then my solution set is negative 8. Okay. Number 2, same story, cross multiply. I'm going to get 3 times 2a plus 1 gave me 6a plus 3. And then 7 times a minus 8 gives me 7a minus 56. Get your variables on one side, your constants on one side. I get negative a is equal to negative 59. Divide both sides by negative 1, and I got that a is equal to 59. Again, double check, make sure you're not getting 0 in the denominator, and it checks out. For number 3, cross multiply. So what changes here is now I get a quadratic, so I could have two solutions. That's possible. Okay, so anyway, cross multiply, I'm getting r squared is equal to 4r minus 4. And then I'm going to send everything to one side of the equation so I can factor and solve. When I do that, I got this expression here, and that factors out to r minus 2, r minus 2. So then my solutions are exactly the same. R is equal to 2. When I plug this in, you can see that it checks out. So my solution set is just the value of 2. For number 4, I cross multiply. 3 times 8 is 24. And then m plus 3 times m minus 2, I get this quadratic here. Okay, it's a product of binomials. You can pause if you need to work those out slower. Get everything on one side, so subtract 24 from both sides. I got m squared plus m minus 30. This factors into m plus 6, m minus 5. So then my two solutions are m minus 6 and m is equal to 5. And then you can again plug those in, right? There's only one restriction here, this denominator, but they both check out. You don't get 0. So then those are my solutions. For number 5, I cross multiply. Y times y plus 5, I get this here. Y plus 8 times 3, I get this here. Okay, and then I send everything to one side, and I got this here. I factor this, I get y plus 6 times y minus 4. And then my two solutions would be y is equal to negative 6, y is equal to 4. And then they both check out, okay, because you don't get 0. So then that's my solution set. For number 6, same thing, cross multiply. I'm getting 2 times 3 is 6. And then 2x minus 3 times x plus 4. I'm getting 2x squared plus 5x minus 12. I subtract 6 from both sides. I'm getting this here. Then I factor this here into 2x plus 9 and x minus 2. So then my two solutions would be x is equal to negative 9 over 2 and x is equal to 2. And when you plug both of them back in here, right, especially this one because of the denominator, I don't get 0. So then they're both my solutions. For number 7, this is where method 2 comes in. Okay, you're going to use the least common denominator. So here, notice that I have now on the left side of this equal sign, I have two fractions, right? So then it's not like the other one where I could just cross multiply. So instead of figuring out what the least common denominator would be and merging these and then going from there to cross multiply, you could just take the least common denominator. I have 3n and 6. So then the least common denominator would have to be 6n. So then I multiply everything by 6n, and when I distribute that in to each one, okay, I got 24n over 3 minus 42n over n is equal to 6n over 6. What I did there from here, sorry, is I simplified. 24 over 3 became 8. 42n over n, the n's canceled, and then I got 6n over 6, the 6 is canceled. So that gave me 8n minus 42 is equal to n. So then from here, just solve, right? There's just one variable, so get your variables on one side, the constants on the other, and I got that n is equal to 6. Number 8, similar story. I have k, 2, and k. The least common denominator therefore would be 2k. So I multiply everything by 2k. I got 6k over k minus 2k over 2 is equal to 24k over k. And then I simplified, the k's canceled in the first one, the 2's would cancel in the second one, and then on the other side of the equal sign, the k's canceled. That gave me 6 minus k is equal to 24. I subtract 6 from both sides, and I got this here. And then divide by negative 1, I got k is equal to negative 18. And then you could see that, well, clearly this solution, I don't get 0 in the denominator, so that's my solution. So number 9. Here, this is where things start to get a little bit more complicated. So I have p minus 2 here. This is just 2, but it's really 2 over 1, right? And then I have p squared minus 4, which is really p plus 2 times p minus 2. It's a difference of squares. So what would be the least common denominator? Well, I already have p minus 2 here, and I have, this is really p plus 2 times p minus 2. It would have to be this here. This would be the least common denominator. So I multiply everything by p squared minus 4. When I multiply, right, I put it here too, so you can see what it's really equal to. When I distribute this here, okay, I have p times p squared minus 4. But I know it's p plus 2, p minus 2, and I have p minus 2 here. So this is going to cancel out with one of those factors. So I really just get p times p plus 2 right here. Plus 2 times p squared minus 4. That's this one here. Is equal to, and then, well, if I multiply this here with this, this, and this will cancel, so I get just the numerator, 8. I distribute here in this first one, I get p squared plus 2p plus 2p squared minus 8. When I distribute this here, it's equal to 8. Combine like terms, and I'm going to subtract 8 from both sides so I can get it over to this side, so I get everything equal to 0. And I got this resulting quadratic here. I factor it, I got 3p plus 8 times p minus 2, so then my solutions would be p is equal to negative 8 over 3. Now this one right here, p is equal to 2, did not work, because when I plug it in here, 2 minus 2, I get 0 in the denominator. Here as well, 2 squared is 4, minus 4, I get 0. So then this guy, this solution does not work, so then my solution set is only negative 8 over 3. For number 10, I have 3w minus 3 here. I can look at it as 3 times w minus 1. I have w minus 1 here, and I have 9 here. So what would be that least common denominator between all three? It would have to be 9w minus 1. So I multiply all three terms by the least common denominator. So this times this here. Notice that w minus 1 would cancel with this, and I get 9 over 3, which is just 3, but I still have the 13. So 3 times 13 is 39. Minus 1 over w minus 1, the w's minus 1 would cancel, so I get 9 times 1 minus 9. I combine these and I got 30. For the other side of the equal sign, I have this times this. The 9's would cancel, so I get left with just w times w minus 1, which is w squared minus w. Now I'm going to get everything on one side of the equation, so I subtract 30 from both sides, and I got this here. Then I factor the right side into these two factors, so then my solutions were w is equal to 6 and w is equal to negative 5. So then when I plug these in, you can see that they both check out, so they are both solutions. 2 more. For number 11, I have x plus 3 is equal, whoop, sorry, I'm reading the denominator, x plus 3, and then 2 over 1. So I would multiply everything by x plus 3, because that would be the least common denominator between all three. So for the first one, I get just x plus 6 is equal to 2 times this, right? So 2x plus 6 minus, right here, these guys would cancel, minus 5x plus 12, what's in the numerator. So right here I made a mistake because I lost track of my negatives. Okay, I would get minus 5x minus 12, and then I combine like terms, I got negative 3x minus 6. So then get the x's on one side, I added 3x to both sides, 4x. Subtract the 6 from both sides, I got negative 12. So x is equal to negative 3 when I divide both sides by 4. However, negative 3, when you plug it in, you're going to get 0 in those denominators. So it's not a solution, but that's the only one we got. So this one has no solution. Number 12. This denominator here is really just c times c minus 4. I have c minus 4 here, and this is just 1 over negative 1 over 1. So the least common denominator would have to be c minus 4. So then I would multiply everything by c minus 4. Notice that they would cancel. This denominator would cancel with the one you're multiplying by, so you get just the numerator. 3c minus 2 is equal to the c minus 4 will cancel with the c minus 4, so I get c squared because c times c, minus, then I have 1 or minus 1 times c minus 4, so I just get this right here. So I'm going to get so it's minus c or negative c. I get negative c squared positive 4c. C squared minus c squared, those are going to cancel, so I get just 4c here on the right side. And then I subtract 3c from both sides, and I'm going to get c is equal to negative 2. And when I plug this in, it does check out. See, negative 2 squared would be positive 4, but that would be minus 4 times negative 2, which is positive 8. So it's not 0. When I plug in negative 2 here, I get negative 6, so it checks out. So C, negative 2 is a solution. And that's it for solving rational equations.